Introduce myself, my name is Ashley.
Good day, I'm Mr. Raymond Mmaduabuchukwu Uchebo, the inventor of Geotrigmetric set. You see, the teaching of mathematics in secondary and primary school has been so done only by theoretical method. It has been so teacher-centered and not student-centered. That made the teaching of mathematics to be abstract, and students are running away from mathematics. Based on that, I carried out a research on how to make the teaching of mathematics to be practical. That's why, because of the practical, the research, Geotrigmetric set was invented. And you can use it to verify over 40 different concepts in geometry and trigonometry. That's why the name is called Geotrigmetric set. It has chapters. This Geotrigmetric set, a teacher set, it has the student set. While the teacher using the teacher set to demonstrate, the students will be responding with this, and it makes all the topic that they have treated, those 40 different topics, to be done in a practical form, and it helps students to retain memory what they've learned, and it will help them to improve the teaching and learning, and the performance will be improved. With this, mathematics will no more be feared. Students will now see the friendliness and the learning environment that is available in mathematics, which are not tapped. For instance, when you want to talk of sine rule, you use this material to verify sine rule. You talk of triangle, you take a triangle. By the time we come to the teaching aspect of it, we'll take it topic by topic. But for now, I want to, after the introduction, I will now do the setup. I set this in so that a teacher will know how to set the material. Then I will go over to the student geometry set and show how it can be used. And make a topic and start using it for students. But right now, let us set another one. This is a set now of teachers geometry set. Let us now set another one so that teachers will see how to set it. This is the board. This is the back. It is a protractor bounded by 4 rulers, 1, 2, 3, 4, with 2 other rulers that move about. With this, you can set up shapes and read the values. The values are known. Let us fix it. You now know how it is fixed. This is the stand. This is the stand. This stand is a tripod. You now adjust here and put this to the height you want. See the stand now. You now put it down and adjust this. Then pull this to the level according to your height or the height you want it to stand. Then you bring this bolt, you put it here on this hole. The second one, you put it on this bolt, on this hole. Then you hang. There are 4 holes here, but the middle one is the one that you hang this on. Now apply this washer. Then these are the 2 movable rulers. The 2 movable rulers. This one calibrated here is ruler 6. This one calibrated this way is ruler 7. Ruler 7 is always placed at the left hand side. Ruler 6 is always at the right hand side. Like this. So if you now want to displace this one to the right, displace this one to the left, you can now form triangle. Whatever triangle you want to form, if it is equilateral, then you make here to be 30 degrees, here 30 degrees, so that here be 60, here be 60, here be 60. It becomes equilateral. If it is isosceles, make here 20, 20. 20, 20, 70, 70 accessories. If it is scaling, can make here. Here is 40. If here is 40, and here is 40 degrees, here is 30 degrees. So here is 30, here is 90, 30, 60, 90, 40, 50. So here is 70, 60, 50, making a scaling triangle. That's if you want to talk about triangle. But while the teacher is teaching with this, the student will be using the student type. I just want the teacher, an average teacher, to know how to set this up and how to use it. Now, that's one thing you want to know. The tip of this, the zero, the calibration starts from the tip. If you want to place this, don't place it to pass this ruler, WE. Let this tip should not pass here. If it passes here, it's wrong. If it is under, it is wrong. It must be the tip of this must take the angle you want to. The tip. Then, when you want to take reading, you take reading the internal dimension. This line inside. There are 3 lines here. 1, 2, 3. 1, 2, 3. 1, 2, 3. This internal one is not the area you consider. These ones are just for calibration. The second and third one are for purpose of calibration. The line you consider it is. So if you want to take reading here, you take the intersection between the ruler and this line inside. You take reading from there, which is here. You take reading from here. Check measurement here. Check measurement here. Where they intersect. This is where you take your reading.
Go back to check measurement. You take reading.
For instance, if you want this intersection between the ruler and this place, you measure from here to here. Come down, you know the value. You measure from here to here. Go up, you see the value. You now record the value. That's how to take reading on this. The intersection between the board and this. And where you want to refer to an angle. For instance, if you want to refer to this angle. Where you want to refer to any angle, use marker. This thing, it can wipe off. Use marker to indicate the angle you are talking about. So that when you are talking of opposite to the angle, they will know that this side is opposite to the angle. This side is adjacent. You have to indicate, because one thing with us, you talk of trig ratio, talk of the opposite, hypotenuse, adjacent, you will not indicate the angle. Indicate the angle like this, x degrees. If you indicate x degrees, then this side is opposite to x degrees. Then this side is adjacent to x degrees. That is how to use this one. I've said earlier that the teacher is using this to demonstrate in the class why all the students in the class will bring out this place on their locker. And what you have here is condensed in this macet. People erroneously call this a macet. It is not macet. It is students' Geotrigmetric set, which you can see the content.
No,
See the students' Geotrigmetric set. It is not macet. We don't want to put pear or compass, divider, protractor. This one is just for verifying theorems and make mathematics teach on mathematics practical. That's what is happening. If you want to bring it out, the student will put his or her hand here and bring this out and drop on the table. This is not magnetic, but it has holes. It has holes where you can use this to pin the rulers. When you pin the rulers, you can now displace. This one is calibrated exactly like the teacher's board. Now, these are the two rulers. These are the two rulers. The two rulers are identical. But when you want to use them, make sure you use them facing each other. These two places facing each other. One has, if you want to join them, you bring them up like this, and you use one plastic pin, to pin the two rulers together. When you pin the two rulers together, it forms a bigger ruler. But one has depression below, one has depression on top. But this is the way you put it and fix at end. Then you can now display this. Because it's not magnetic, it has to be on your table. Display it, and it will be there. You take your reading and do your calculation. But the teacher's board is magnetic because it will stand like this in front of the class. But this one is personal to the child. The student will now put it like this, place it anywhere. But just know how to place the two rulers together. This one with depression under is called ruler 6. This one with depression on top is called ruler 7. You put ruler 6 on top of ruler 7 and use your pin to put it together, and it forms a bigger ruler. When it becomes a bigger ruler, you can now pin it at end, like I said before, and it displays. But if you want to put them separate, there is a handbook that will tell you what to do at any time. Say pin ruler 6 at end. You pin ruler 6 at end. This is ruler 6 with the depression under. So place it this way. If you are asked to pin ruler 6 at end, you put it here. Maybe say this place to form diagonal of the square. So this is a square. This is another square. Can pin this is ruler 7 with depression on top. You pin ruler 7, say at W, and this place to form diagonal of this square. Then this diagonal, this is a square, this is a square. This forms a parallelogram. You can see how the two rulers are used. They can be pinned separately this way, facing each other, or they can be pinned together with one pin this way, and displace the way you like. This is ruler 6 with depression under. This is ruler 7 with depression on top. If you ask to pin them together, you put ruler 6, push them to meet each other. With depression on ruler 6 on top of depression on ruler 7, you will now pin them together and pin at end. Then displace this way and this way, depending on what you'll be told in the handbook. You displace them according to what you are told in the handbook and take readings. You do the calculation and you get results.